The liquid metal technology is unique in that it's the only process I've seen that really allows you to design truly for function. Simply put, most product development engineers are tied to having to design around the process itself. So if we're machining, we're removing material. With each machining step, you add costs. So there's some restrictions. So if I'm thinking about a geometry and I want to produce that through machining, then I'm tied to machining steps and costs to achieve it. So it might restrict my thinking on how I would apply my design. If I'm using stamping, then I'm dealing with a sheet of material and what can I stamp and form that sheet into. There's restrictions there. So my thoughts around product development are limited to the restrictions of that process. Metal injection molding is another three-dimensionally complex metal part forming technology, but it has restrictions that are unique to its process. Those parts shrink 20% when they're in a furnace. So if you have a component with a cantilevered arm, you can't produce that unless you're willing to accept some distortion. Well, with the liquid metal technology process, you can mold that part complete. When it comes out of the tool, there are no post-processing steps that influence the dimensional results of the part, so you can provide that kind of feature. Investment casting can produce fairly complex parts, but you run the risk of internal voids that are often found in investment cast components, rough surface finish at multiples worse condition than you'll get from the liquid metal technology. So now as a product development engineer, you find yourself being limited to those constraints around that process technology. So with liquid metal, it's almost endless the amount of design variation that you can achieve with the process technology. There aren't any of those constraints. If you can produce it in a mold, you can get it in a metal part. No other restrictions.